Myself, shinas-Kera. I'm from Department of Mechanical Engineering, Nusaputra University. So this is my research presentation, Kera Harnessing Rail Side Wind for Kerala's Electricity Resilience. Kera is a project title or the product title. And Kerala is one of the state in India, like a territory, and my home state. So through this project, we are trying to somehow sort out the problems that is faced by Kerala in terms of electricity production and power consumption. So the contents of the presentation are introduction, graphics and working, data and discussion, and estimated expenditure, which is one of the most important part, because if we want to present a new type of initiative, it should be economically feasible. So introduction, wind energy and contemporary solution. Kerala currently produces most of its energy from fossil and hydroelectric power plant. Yeah, Kerala is a state which relies on both fossil types of energy production and also renewable hydroelectric power plant. But last year, some of the last recent years, Kerala received only 40% less rain availability. So the rain availability is decreasing. So this is a concern, and we can't somehow be predicting the hydroelectric power plant production for next years. So it has in the good future in terms of Kerala's electricity production. So next one is why in Kerala? Because Kerala, as I said, Kerala produce electricity by its own, but most of the electricity is bought out from the other states or some kind of industries. So this causes government a huge economic burden. So if we are able to sort out the problem, which will be giving a free in the economic terms, and these funds can be allotted for some kind of public developments or public infrastructure developments or welfare of the people. So the wind is the main type of turbine. Sorry, wind is a solution that is put forward by me. So there's typically two types of wind turbines: horizontal axis wind turbines, which is somehow seen in everywhere. We have seen it in many times. Most of you have seen in many wind plants. And the second one is vertical axis wind turbines. So we are opting vertical axis wind turbines. So the reasons will be coming in the presentation in short time. So challenges of, we said we are not opting horizontal axis wind turbines. So why? Because buying and setting up the turbines is costly. If you want to make a project which is good for the society, it should be economically feasible. So the government and the state is already in economic burden in terms of energy consumption, energy buying, energy production and all. And if you are initiating a project which is more costly, it doesn't make sense. And second one is maintenance and repairing is risky. The maintenance of the wind turbines, which are helical, horizontal axis, which is very risky, and it creates sound pollutions. So in the sustainable era, we are tending to avoid every kind of pollutions and some kind of disturbance. So something that produce sound pollution, it's not for the sustainable era. And land space, it occupies a huge amount of land space. Kerala is a state where the density of the humans are very high because the peoples lives in compacted area, congested area, houses after houses. There's no such types of long free house areas in Kerala. And why vertical axis wind turbines? Vert, Vertical axis wind turbines can operate in low speeds because the horizontal axis wind turbines only operates in the high speeds, but vertical axis wind turbines can operate in low speeds, which is a very well defined advantage because producing electricity even though from the low wind speed, which makes sense. And second one is lower cost, and the repairing and maintenance is so easy. There are four types of watts, means vertical axis wind turbines: Savinius, Darius, Rotor, H. Darius, and Helix. We opt Helix. The next section of the presentation is working and graphics. So the components, main components are numbered here and mentioned in the diagram. next to it, blade, spacer, AC generator, right plate, gear input, top bottom rod, bearing housing, base plate. Base plate is needed in both top and the bottom. So you can see in the presentation, which is very well numbered. And the working is simple physics. Wind blows, difference in air pressure. Differences in air pressure creates force. And due to this force, turbine starts to rotate. So after the rotation, the electricity is produced. So the third section is datas. Sorry. Third section is datas. So we collected this data from literature study and by the assessing the site of plantation, and in 2 meter per second wind speed electricity can be produced 0.1. In 5 meter per second 0.5 kilowatts of electricity can be produced according to the theory and the literature. 10 1 23 35. So the site of plantation is it's a initiative project. So we are suggesting it to be implemented on a short area, and if it is working, somehow the theory is possessing, yeah, we can enlarge the project implementation. So Tirur and Tirunavaya, two railway stations, were selected as the in between this site of plantation is selected. Why these sites were selected, you can see from the data is written below that. Average speed of the trains between these two stations is 110 kilometer per hour. It is somehow recordically high. Average speed 110 is a high speed in Kerala's railway transportation. And distance between turbines, each turbine will be departed by 10 meters, and distance of plantation will be 10 kilometers. Within 10 kilometers, the project will be implanted. In between each turbine, there will be 10 meters distance and minimum number of trains per day. This is the least count. 10 trains will be passing through these sites which we selected. 10 trains will be passing. This is a least count, which is one of the busiest railway tracks in Kerala. We can expect more trains to be there. Wind speed is average 25 meter per second, and number of turbines we are gonna plan 1,000 turbines. Electricity produced 1,000 kilowatt per 7 seconds, and per day we can expect a production of 6,000 kilowatts. It may be or 60 megawatts of electricity can be produced according to the theory and the planning. And the next one is electricity distribution. Uh, because in Kerala, households need electricity, industries need electricity. So if the electricity produced from this project, how it can be distributed? It's a most important question. So step one is electricity is produced in the turbine. Step two, high amount of electricity produced from turbine is transferred directly to the nearby KCB substation. KCB is the Kerala State Electricity Board, which is dealing the electricity related every kind of steps in the state. And the third one is transformer converted electricity from high voltages to lower voltages. And the fourth one is electricity delivered safely to electricity consumers, that may be households, industries, hospitals, or any kind of things. And last but the most important thing is estimated expenditure. So we mentioned each things that we need for a one turbine and its material. You can see the second column is about material. This one is about material and the quantity we need and the price. Price we can expect from this. So helix bell ABS 3 we need 4,500. Triplate 11060 alloy 2 we need 6,000. So when we add up all these, approximately one turbine costs 49,800. I have to mention this money is recorded in Indian rupees, 49,800 Indian rupees. So if you need to get your onto your currency, you have to convert. Analysis: total turbines 1,000. For one turbine, 49,800. Once again, I'm mentioning this is Indian rupees. For total expenditure is about 4 crores 98 lakhs Indian rupees. Electricity produced each day is 60,000 kilowatt. And two more datas. One is 10516.32 million units Kerala produced from all other sources. fossil fuels, hydroelectric power, everything. And 18,402.516 million units Kerala buy from outside, which the state have to pay, and which creates an economic burden in the governments. And if we are somehow able to sort out this problem, that funds can be allotted for some kind of infrastructure development or welfare of the peoples. So last conclusion, able to capture wind from all sides. Efficiency can be increased by changing the size and shape of the blade. The potential to make significant contribution to global effort to reduce our reliance on fossil fuels. Because globally, we are moving to a sustainable era. The fossil fuels are no more encouraged. The fossil fuels are no more endorsed by any kind of country which is hoping for a better future. So we are a state which is very passionate about the future. So we have to be showing an example to the world that we produce our electricity and power from renewable sources. Second is major objective of our project is to release Kerala from paying rents for electricity to other state. It's one of the most important outcomes that we expect if this project is implemented. Make Kerala self-sufficient for electricity. Self-sufficiency should be attained in every kind of sector, education, public, governing everything. So this project endorse state to be self-sufficient, which is one of the most important qualities. So this is all about the presentation, and thank you.